So we're looking now at the average of some numbers. Somebody say, what's the average, what's your class average? There's a lot of ways to find averages. There are weighted averages, which are special averages, like your average for this class would be weighted average. We give a certain weight to your tests, your quizzes, your homeworks, and stuff like that. And we put them all together, come up with a final average, including the final exam score. But we're going to look at some kinds of averages. A lot of times people think when you want to find the average of some numbers, you add them all up and divide by how many there are. That's one kind of average. Another average would be what number's in the middle of all the values in the list. Some people think that the average might even be coming from what number shows up the most. Let's look at these different kinds of averages. There are several ways to generate a statistic to describe the middle or average of a data set. Data is all the points that you have, and if we want to find the average of a data set, we can find it, and a lot of times people just add up the numbers and see what they are when you divide by it. That's one of them. One is the mean, which is equal to the sum of the points values by the count. So you'd add up all the values and divide by how many there were. If you bowl 3 scores, a 200, a 150, and a 100, you'd add them up and you'd see that your score there was added up to 450 divided by 3 and you're at 150. So that's like bowling 3 games and putting them together to see what your average was. That's just the average of the 3 games that you bowled. The median. And that equals the middle value of an ordered list. You need to sort your values, put them in order, and then you can go ahead and try and find the middle of the list. Now, that's easy if you have an odd number of values. But what happens is the position of the middle is equal to n plus 1 over 2. N is the number of values in the list. And if a value shows it more than once, you count it more than once. You list it twice, 3 times. But n plus 1. 1 is the position of the first one in the list, and n is the position of the highest position in the list. You want to average the n's of what are called the indices, the indexes, that count your positions. You want to take the last position plus 1 and divide it by 2. Because there's the first position is the lowest score and the nth position is the highest score. Get the average. If you put an odd number in there like 9, 9 plus 1 over 2 gets 10 over 2 gets you 5. You're right in position 5. 1, 2, 3, 4 are below it. 6, 7, 8, 9 are above it. And the 5th one's right there. But if you have an even number in there, like 6, 6 plus 1 is 7, 7 over 2 is 3.5. That means the position is between 3 and 4. It's 3.5. And you would land between 2 numbers, and then those you would take the mean of them, because you can't take the median of empty space sitting between 2 numbers. So then you're forced to take those 2 values, add them up, and divide by 2. The mode is the most frequent occurrence. At least you have this going for you. If you have the mode, it's guaranteed to have happened the most. So the most people will be like, I'm right there. I'm on the most frequently occurring number. The mean does not have to be an exact value that anyone had, but it will take all the points that were totaled and divide them evenly across all the people that did it and see what you get, and a lot of people consider that the average. The median will find the middle of the list to find the middle position. Half the people are above, half the people are below the median. The mode is the most frequent occurrence. That'll be the one that has definitely got people that do it. In fact, the most people that get it, but it may be very far to one side or the other of your data set. It might be very high or very low because of the frequency of that kind of number occurring. And then we have this one. If all you know is the 2 ends, you can average the maximum and the minimum by taking the extremes, and sometimes that's all the information you have, and divide it by 2. Average the 2 extremes. And that just tells you what's the middle of high to low. What's the middle of that? No matter where people fall, at least this is the middle of all the values that we had. And these are all ways of representing the tendency of the center of your data set. So I want to set up some scores from a golf match that went out, and there was a 70. Golf, the low score is the best. So when people say you're not up to par, in golf, you don't want to be up to par. If you're really good, you want to be below par. But that's a whole separate story. 82, 81, someone scored 69, 89, 85, and 83. And we want to find the values for these people. So what we'd like to do is go ahead and add up all their scores and then divide by how many of them there are. So I'm going to put some indices. Index is one of them. Indices is if there's more than one. 1, 2, 3, 4, 5, 6, 7, 8, 9 people came in from golfing. They probably go out 3 at a time, and they come back in, and as they finish their rounds, they list their scores. So it doesn't tell you who got the best score, it just tells you who came in earliest, and it's not a race. So these are the 9 scores that came out of it. We're going to try and find the mean. So go ahead and get the total of all those values, add them up, and then we'll see what we get when we divide it by 9, because there are 9 values. 70, 146, 226, 231, 301, 303, 304, 384, 444, 453, 533, 542, 547, 627, 630, and 710. See how I did today. $720 seems to be the number that we got for the total. So I was off by 10. Okay. Anyway, add them up. You should get 720. Divide by 9. The mean equals 80. So that would be, we'd say, the average score of a golfer that day, because we're going for the mean, is 80. But what I want to do is take the blue marker and put the scores in order for a couple of other things that we've got to do. Now what I'll do is I'll leave those blue numbers up there for the positions, but the lowest score, the only one in the 60s, is this score of 69. That's done. Then we got that 70. Anything else in the 70? Also a 76. A 70 and a 76. And if I miss one, normally students would let me know, but there's nothing else in the 70s. We now hit the 80s and we got 82, 51, 1, 2, 3, 5, 5, 9, 81, 82, 83, 85, another 85, and an 89. I don't know how hard the course is or what par is, but these are the scores that came in. 69 was the lowest, and that would seem to be the winner. So we've now got to figure out what is the median. And we'll use red to find the median. N equals 9 scores. 9 plus 1 over 2 equals 10 over 2. We're looking in position number 5. We're looking right here where the 5th one is in order. Median is score. Number 5 when they were put in order, and that is 82. Now if we look, you feel good if you did better than average in golf. Better than average is being below the average that people had. And if we look at what happens here, the mean score, the average of all the strokes divided by the number of people is 80. 1, 2, 3 people did better than that. 1, 2, 3, 4, 5, 6 people did worse than that. Which means 3 people feel good about being better than average, and 6 people feel worse because they're worse than average. However, if we take the median, it guarantees half the people will feel like they're better than the middle, and half the people will feel like they're worse than the middle. Or at least this person with the 82 is right in the middle. We got 1, 2, 3, 4 people who feel as though they're better than the middle. One person feels he's right in the middle. 1, 2, 3, 4 people feel worse than the middle. But the median guarantees a balance on each side. The mode is one of the least useful ones in my opinion, but it's worth noting that it happened the most, so it's most likely that 2 people would talk to each other and say, hey, I shot that too, we must all be all right. But anyway, the mode. When they're in order, it's easier to tell the mode. 69, 70, 76, 81, 82, 83, 85, 85, they come together at 89. The mode here actually is the 85. So now, one person did worse than the score that the most people had. So what does that say about the middle? Not very much, but it does say what happened the most frequently. So if you're like, if you had an 85, you're not alone. That's about all you can say about this crew right now. And the mid-range. The mid-range only takes the values of the extremes, which the lowest is the value we've already got up there. Let's see where the black mark go. The mid-range takes the two extreme values, 69 at the low and 89 at the top, and averages them together, 69 and 89. 80, why did I say 6, right? 89. And divided by 2. 158 divided by 2, 79. 79 would be right there. So when you look at the mid-range, the way these are distributed, 79 seems to represent the middle. Wait a minute, something happened. One person really was out there, hacking it up as they say. This person did a lot worse than the rest. He did, I don't know, he must have gotten lost from his group. Maybe he went out to play by himself. But this person came in a lot later. He scored 140. And that is the highest score. It's the last score to come in. It's score number 10. It's the highest score at 140. And let's see what happens now if we look at this 720 and we want to find the new mean. We don't have to add them all up again. We got 720 from the first 9 players and 140 from this other one. Now there are 10 players. 860 over 10, 86. The mean just became 86 because one person did significantly worse. We're now going to look at what it does to the median. We do have that extra score on the list. It's on the high end. N is now 10. So 10 plus 1 average the highest count of position with 1, and you get 11 over 2, which is 5.5. And we go to position 5.5. And it's between the 5th and 6th position. So now we're going to have to go ahead and add 82 to 83 and divide that by 2, and we'll get 82 and a half. So the median shifted by half a stroke, even though that person came in with 140. And the effect of that is that there's one more person on a high score, so it moves the location of this up. But now we're 1, 2, 3, 4, 5 and a half right there. And even though he's on the high end, it's not how much worse he was, it's that he was one of the worst ones. Because if he had come in lower than, say, the old 82, he'd be in here and it would push the 82 up to a higher score and the median would come down. But it didn't go up by very much. The mode, the one that happened the most, stays right on 85 because still that's the only one had by more than one person. And the mid-range, we'll see how that gets affected. Mid-range now needs to be recalculated using the 69 for the low score and now 140 for the high score. So that's 209 divided by 2, and that's 104.5 because he reset the scale of the high one by quite a bit. He scored 51 strokes higher than anyone else had, and that did have an impact on what used to be 79 is now 104.5. Right? 79, actually, the mid-range used to be the lowest. Now by far it's the highest because it's so heavily influenced by extreme values. So that's how we find the values of these numbers, and we look at how the impact comes in. And what we have here is, why is one affected so much by outliers? And that's the word that we use is resistance. So resistance is hesitation, holding up, not being moved very easily. And so we're going to look at the resistance of these values, but the resistance of a value is its ability to maintain itself through outliers. Resistance of a statistic, in this case, worried about outliers, is its ability to hold up, to hold its value in the occurrence of outliers. what we're looking at is what happened to the mean when we had that 140 come in. It jumped from 80 to 86. What happened to the median? It went from 82 to 82.5. It moved up half a notch. What about this mode? It didn't get affected at all because it didn't change what had happened the most frequently. And the mid-range, because we had an extremely high value, that was very much affected by that new high score. And so we're looking at resistance. The greatest resistance seems to be the median. Let's not even count the mode because it's a funky number that holds its own in different ways. The mean is not as resistant as the median to outliers, and the mid-range is crazy. If you get an outlier, it can throw the whole thing way out of line. Although the mean is subject to some of that feeling, the median tends to hold its own. So we can look at the numbers that people look at when they talk about house prices and incomes. The reason that we want to look at these is we want to look at affordability of a house in a certain area. Okay? So we're going to take a look at some house prices that I'm going to make up for a place we'll call Bridgetown, Connecticut. And these will be based on thousands of dollars that you pay for a single family home. Bridgetown is located on the water, and it has some expensive houses and some houses that are far more affordable. So we'll look at a house that costs $79,000. We'll then see a house that costs $85,000. We'll put, semicolons instead of commas because what's coming along is something that'll matter a great deal in a little while. Now we'll have 120, okay, and now we'll have 150, another one at 175, and then we'll have one at $880,000. 1, 2, 3, 4, 5, 6. Oh, we don't want to do that yet. And we'll have another one that comes in a little bit later at 100,000. So they're not quite in order yet. We'll put them in order. We'll get the 79, the 85, the 100, the 120, the 170, the 150, the 175, and the 880. Now, what's the deal in these houses in Bridgetown? How come one costs $79,000, one costs $880,000? I'll let you know. This town has some waterfront property. Guess what? That's probably the waterfront property. I don't know how big it is and all that, but waterfront seems to be something that people seem to cherish and pay a lot for because they're not making any more of it, so I'm told. Now, we want to find the values for these. So I want to go ahead and find the values for these. I want to find the mean, so I want to add them up. I'm going to add the 7. I'm going to go with the ordered list. And 79 plus 85 plus 100 plus 120 plus 150 plus 175 plus 880. Okay, 1589. 1, 2, 3, 4, 5, 6, 7. Mean equals 1589 over 1, 2, 3, 4, 5, 6, 7. 7. See about what the average, according to the mean, house price is. Divide by 7, and it equals 227. That's thousands of dollars. So when people are looking to move to Bridgetown and they say, I want to buy a house in Bridgetown, like, good luck. The average house costs $227,000. I don't know if you can make that mortgage and payment and all that. Let's look at the median. 1, 2, 3, 4, 5, 6, 7. N equals 7. N plus 1 over 2 is 7 over 2. Sorry, 8 over 2. I can add 1. And that's 4. Position 1, 2, 3, 4, 5, 6, 7. Median. 120. There's no mode, and the mid-range is kind of silly. You'll add 880 to 79,000, get 959, and cut that in half, and you're going to get about 480,000. So we won't even bother with that. But we'll look at this. What does that say? Now, if this is a small representation, or maybe a small town, this can help you understand what they want to do is say, look, half the houses in Bridgetown cost less than 120,000, and half the houses cost more than 120,000. Now, if you think that you can afford a mortgage on a house that costs 120,000, you could move to this town because half of them are in your budget. And who knows, the way they work things, maybe you could actually afford 150. And there might be a bunch of other houses scattered in here, but this might be the way things are spread out in the range, and we come up with those numbers. Which one do they use? Do they use mean or median to describe the affordability of the town? And the answer is they use the median because they want you to know you can afford half the houses in the town if you can afford 120. They don't use the mean and have people thinking 1, 2, 3, 4, 5, 6 of the houses are below the average price and have one above average. So they use the median for that. Another thing they use median for is for income. And I could get started, but I'm going to try not to, about income. What happens is, if you have a high income, you take up one of the spots on the higher half of the median. If you have a low income, you take up one spot on the lower end. But if you make $2 billion this year, and another person makes $1,000, it becomes $2 billion and $1,000 cut in half to $1,500,000, and that's the mid-range. Or if you're averaging those two people, that would be the average. The billion is really going to play a big role on the mean. So what we tend to go with is the median and see how you are in relation to the middle. And I want to show you how to get these numbers on a graphing calculator. Now, if you don't have a graphing calculator, there's not much left to do here. So you can be done with this, but the graphing calculator has values on it that I want to put in here and show you how it works. What the graphing calculator wants to do is it wants you to come in here and put the data values in as you have them. So I'm going to put the data values in the way I got them initially. And they're going to be number 1 is 79, 2 is 85, and on up, then the 7th one will come in as 100. And that's fine. Here's how we do it. If you have a graphing calculator, of course you turn it on, and we're going to do something with statistics. So you hit the button third in from the right, from the left on the second row. It should say stat. Hit stat, and now you're into options for statistics. We now want to edit our list. Now what I have here is my first list, since it's not a new calculator and I've used it before, is filled with data values. So mine says list 1, and it's got for some reason 2, 4, 7, 11, and 901 from something done earlier. I want to clear that out. I'm going to hit the clear key. So if you're list 1, if you're not on list 1, move over to list 1. If you are on list 1, stay there. But if your list 1 has other values in it, hit the clear button. It won't do it yet, but it's going to point to list 1 and item number 1 in your list. It's going to say, what do you want to do? It's blinking at you. If you hit enter, it'll clear, should clear the list. What did it do? Oh, let's see. Clear. Oh, wait a minute. Why? I've done it. Oh, it's been a little bit for me to do this. Let's get back to data. Stat. Edit. All right. Let's see. Oh, I know what I'll do. I can delete the values one at a time until the list is gone. I can take them out one at a time. So if you put a value in you don't like, you can delete it. But we don't want to delete the whole list. We don't want to go up on the name of list 1 and delete it out. Let me try something here though. Yeah, that was it. If you want to clear an entire list, you can go up onto the name of your list and then hit clear. Don't hit delete, and it will clear out the list for you. It'll then be blank. Now we can start entering these one at a time, hitting enter. So we'll go 79. I'm doing the top one. Enter 85. Enter 120. Enter 150. Enter. Take a look now. You've now got. You should have. I didn't hit enter at the right place. I have 79 good, 85 good. Now I have 120,150. So you don't have what I have necessarily. I'm going to clear out that value. I'm going to put it in again. I'm going to get on that value. I'm going to delete it. And after my 85, I'm now going to put 120. I'm going to make sure to hit enter. Then I'm going to hit 150. I'm going to hit enter. I'm going to hit 175. Enter. 880. Enter. And 100 at the end. Enter. And now what that says is it's looking at list 1 and it's waiting for me to put in number 8. If I don't do it, it'll go with the 7. But it's ready for more to come in. My list 1 is ready to work with. Now what I want to do is do some stat work. So I want to hit the stats button again. I don't want to edit my list anymore. I'm all done with that. I want to do some calculations. So I hit my arrow to the right. And it now highlights the calc option to calculate some values. And I want to do number 1, one variable statistics. So I'm going to hit enter. It says name your list. You're probably still pointing at the list you worked on, list 1, or whatever other list number you want. But you can go ahead and hit, if it's not on list 1, you can hit second, the blue key, and then the list number from the blue numbers. I want list 1. Mine used to be on list 5. I hit it on to list 1. I hit enter, and now it says, what's your frequency list? It's looking to see if you want to do a weighted average, which will tell you correspondingly how much each part of what you have is weighted. We don't want that, so we leave it blank, and we go down to calculate, and then we can enter. Now if we look at this, it says X bar, that is my mean. The 227 is my mean, and that's what I found for my mean also. It's got the sum of my values. I can find that also if I want the sum of X. But it's got some other things in here too. It says n equals 7. That means there are 7 values. I mean, there's these things coming up next week in our next lecture that are coming up. Sum of X is 1589. I've got that I divided by my 7. Then I got my 227. Down there, Sx and rho sub X. N is that there are 7 values. The minimum is 79. The first quarter is called to be 85. The median is listed here at 120. And then it says at the third quarter, you've got 175 and the max is 880. Think of it like a basketball game. This is halftime, 4, right? Halfway between 1 and 4, all right, you're gonna see that these 3 values lie before we get there, that's in the middle. These 3 values lie out there, that's in the middle. And you're gonna find your values for different quarters. So those will be your quartile measurements of where they are. But mainly we look at the median, which is in the middle, 120. The max is helpful, the min is helpful. They can help me get the mid-range and stuff like that. But this finds the whole value. Now, if we want to find out what would happen if we took the 880 out of there, all we have to do is go to our stat, edit, and go find our 880. And while you're sitting on the 880, go ahead and delete it. Now we can run the statistics as though the 880 wasn't there, and the whole thing will run for us and get us the new values. So if we go ahead and say if we took the 880 out, because maybe we think it's an outlier, we can now say what is it that Bridgetown is like if we don't count the 880. And we'll go to stat, and we'll go to calc, and we'll go to run the one variable statistics. It's still list 1, no frequency, calculate. And now it says the average price is 118,000 if you don't count the 880. And what's the median in that one? Well, then the median is 110. And down the list, we can see the max now is 175. Now, if you want to put that back in, you certainly could. And so we can go back to edit. We'll go to stat. We want to edit. We make sure we're on the same list. We could jump to the bottom and insert the 880 if we want. And enter, and now we can rerun it. Or if another house comes in, we don't have to do all the math again. We can increase the data set, run the process again, and it'll be able to find that for us. So this is a quick way to get through some of that, but if you think that's quick, you should see what it's going to do when we do standard deviations. And that's not in this lesson, but it will be coming up soon. So this calculator is a good tool to have for that because you're treating it as a set of data, and this is computing for you all those values because it knows the process of getting to those values very quickly. This is not a calculator. Okay, this is actually a computer that happens to fit in your hand, but then the same can be said of most of our cell phones. And that's what we're going to do. That's what we do with averages. So when someone says, I know what the average is, you have to find out which one they're doing. Are they taking the mean, which is what the street term is average for the mean, but is it the median? And median is used more frequently in places where people are trying to find the middle of where people will fit in. So it's not just one thing that's automatically considered the average. Okay, we're going to go into the homework that combines homework 8 and 9. Very soon we'll be able to get into that.